Hello, it's Jasmine again. This episode is going to be dedicated to something that we skipped over, and I wanted to clarify and to show you how to get your first installation going. And the thing that I'm talking about is Dockers or containers, depending on which version of the nomenclature you're using. So let's roll the intro and go directly into what containers are. Okay, the thing is this. We used to have a lot of applications running in operating systems in the last 50 years or so. And one of the biggest things that happened in the computing world was when we realized that we could share the same hardware, and then on that hardware run virtual machines or separate entities or separate environments in which we can run our different applications side by side. Now, the thing is that if you are running a virtual machine inside your computer, and this is something that almost all of us have been doing if we are using the computers for the last 5 to 10 years, what you're doing is you are wasting a little bit of your, or a lot of your computing power just to emulate what the virtual machine is. So my idea today is to try to explain the idea of Dockers and go through what Dockers are, what Dockers aren't, and how to install your first instance. Now, what I'm going to do is I'm going to switch over from my image that I'm using right now, and I'm going to go and create another virtual machine on my Proxmox cluster, which is getting quite crowded, I must say. I'm going to call it Docker test. I don't care about the name, and I don't care about anything else other than it's going to be an Ubuntu Live server. I'm going to say this is going to be this. I'm going to create a little larger this than it is, but I'm not going to use it anyways. Let's go with next. I'm going to give it more cores, so let's say 8, and I'm going to give it 16 gigabytes of RAM, and then I'm going to connect it to the internet. Okay, so this is my machine prepared, and when my machine stops being created, and it is going to show up somewhere here probably, just give it a second. Okay, here it is. I'm going to quickly start the installation and quickly go through the regular installation that we have already seen a couple of times, but this time this is Ubuntu server, not the Proxmox, not the Android, not all the other things that we installed. So this is a straight Ubuntu install, and what I want to do is I want to get it running in the background while I'm talking about the Dockers, so that we can when we are finished with this thing, that we have something to demo on and to explain how the Dockers work. I'm going to go mostly with the defaults. So if you haven't installed Ubuntu yet, please try to do it under any virtualization software. Installation itself is simple. You just say which language you're going to use during the installation. You can then choose to update the installer. I usually do this because usually if there is anything new in the installer, it is going to be installed with the new installer, and then this update itself is going to be quite quick. Now then, this is the keyboard configuration. At first we were required to say what the language is going to be for the installation itself. Now we define what the keyboard layout is going to be. I'm going to go with the English keyboard, although I have my Croatian keyboard in front of me, but English keyboard is more or less the default. Then it asks me what do I want to install. I'm going to go with the normal regular Ubuntu server. I could install Minimize server, but I want to have some control over what I'm doing. So I would like to see some different device drivers and different things, or specifically different utilities that don't come with the Minimize version. So I'm going to go with the Ubuntu server. Now it's going to try to detect the network. It should be able to do so. So I have an IP address and the proxy is going to be empty. It's going to connect to creation archive. Then it should probably, or it should download the package list or the list of releases in the packages, and it should enable me to go next. I'm going to go and use the entirety of the disk that I just created, and I'm going to set this the LVM group. The reason why I'm doing this is that if I ever need to do anything to my disk, or if I need to expand my disk, having the system disk on the LVM group means that I can just simply add additional space and that's it. Done. It is going to show me what it intends to do. I'm going to go with the defaults. Just make sure that you understand that the default when Ubuntu installs is that it is using half of the available volume group. So it's going to leave free space on the device. Half of the space is going to be free. Now let's go done. It makes sure that I want to format the disk. Since this is a virtual disk, I don't care, so continue. My name is going to be ThatITShow, and I'm going to call my server test Docker, and I'm going to name the user demo and create the password. I don't want to participate in the Ubuntu Pro program, so we just continue. I need SSH, so I'm going to say done, and here I'm going to tell it to install the Docker container runtimes. So I want it to install automatically whatever is needed for the Docker to run. Now the only remaining thing to do is to press done and wait for the installation to finish. So while this is happening, let me explain. What I did here is I basically installed the operating system. Now, when you are dealing with the regular virtual machines, what you're doing is you are installing something called a hypervisor. Hypervisor is usually either an operating system and then a hypervisor on top of it, and the hypervisor enables the kernel to talk to the virtual machines. Or if you are dealing with bare metal hypervisors, hypervisor itself is the kernel. So it is directly talking to the hardware on one side and the virtual machines on the other side. Then when you create the virtual machines, what you do is you create guest operating systems, and on top of the operating system inside the virtual machine you create your application and then run it. This means that all the applications have their own operating systems. This gives you a great amount of flexibility because these can be different versions of operating system. This can be different operating systems completely. So, for example, this could be FreeBSD and then the Linux, then the Windows. And we can run different applications inside different operating systems on the same hardware. So this is usually the same hardware machine, and then you have your virtual machines running inside the hypervisor. Now, the reason why we switched over to Dockers, or why we invented Dockers and decided to use them, is that we wanted to make sure that the hypervisor is closer to the application. And to be more precise, we wanted to move the operating system for the guest from the virtual machine itself into the hypervisor. So the operating system and the hypervisor are the same thing, using something called a Docker or a container, Podman, whatever, depending on the distribution. Because the Docker itself is the trademark name, we are generally calling them containers. So what we do is we install an operating system and then we install the Docker system on top of it. Then all we have to do is install different applications. The applications themselves are the Dockers. So when I say that something is a Docker or something is a container, this means that I have the application and all the necessary dependencies for the application installed inside a package, and this package is self-sufficient to be able to run the application on the Docker. The Docker then uses the operating system to run the application, and if you compare these two images, you can see that we have only single operating system, not multiple ones. So a lot of resources are not being wasted on the operating systems, since I have only one. Now the Dockers, the reason why Docker exists, and the main purpose of the Docker itself here is to create separation. So all the applications are running separately, the same as if they would run in the virtual machines. All of them have their own separate memory spaces, process spaces, disk spaces, and so on and so on and so on. So the applications themselves behave like they're running inside virtual machines, but we are not wasting the processing time for the operating system. This is what Docker is in essence. Now, there are nuances that also need to be talked about, and I'm going to probably be covering those in one of the next episodes. But the idea today is just to go through the quick primer on the Dockers and how to install them, and then we are going to go and try to understand how to actually run the Docker, how to connect it to the outside world. Okay, let's check on my installation. My installation is not yet finished, so let me go back here and let me go through what the Dockers can do. There is something called the Docker Hub. What Docker, the company, because the Docker itself, as I said, is a name, and this name is registered to the company called Docker. What they did is they created a hub of finished Dockers. When you want to create a Docker, what you're doing is you are creating image, and this image contains whatever needs to be done, what needs to be contained, so that you can actually run your application. For example, there is a Docker called Hello World. Let me go back to the Hello World, and this Docker is the official image, so this means that somebody from Docker actually created it, and this is the minimal Docker that can be run. What this Docker does is that when you run it, it just simply outputs the text. It's going to tell you that your installation of Docker itself is fine and that you are able to actually run the Dockers. Now, I just want to go quickly through how this Docker is created and what the Docker itself contains. Now, first thing is that when it comes to Dockers, you're going to see that each Docker has its own tags. Tags are names. When the Docker is being created and when the Docker is being basically described, because it uses a document that describes what's inside the Docker, you can actually say that the Docker called Hello World has its own different architectures, has its own different versions, has its own different whatever you require. And then you tag them. So for example, this one is called, actually it's called Hello World Nano Server LTSC 2025. This one is called Hello World Nano Server. This one is called Hello World Linux. And so on and so on and so on. Usually, when you are pulling the Docker, if you do not use the tag, so if you just leave the tag empty, it's going to pull the Docker that's going to be described as latest. So this is going to be the latest Docker tag that is currently available. This one has been created 15 days ago, and you can if you click on it, you can see what is inside the Docker itself. So you can go to build kit, and then you can see what is inside the Docker itself, and you can see different changes, different packages, and so on. Since this is the simplest Docker that there is, it just simply exists. There is not a lot that you can check. You can just see what the different versions are and what the different tags exist and what is the structure of those tags. Now, the Docker Hub enables you to change and find the Dockers that you need. For example, the last time I installed Pi-hole. So let me just see if there is a Docker called Pi-hole. There is. Or for example, if I need something like MySQL, there is a Docker for MySQL. If I go to it, then I can see that there are different versions, there are different architectures, there are image updates, so on and so on and so on. It describes how to start it, which switches it requires. It explains how to connect to it, what do you need to tell it in order to make it work. So you're required to create the user root password, and so on and so on and so on. But the thing is that whatever you need, it is usually available in Docker. And the main thing that defines Docker as something that is extremely useful is that once you have this machine running, and when you have the Dockers running, what you can do is you can quickly install whatever applications you need, and you can then quickly connect them together. Now, my machine is finished. I'm going to reboot it. And I'm going to go back to the machine itself. So, what is the reason why I even create this thing? Docker needs the operating system to run. So now what I did is I created this host operating system. I also installed the Docker on it. So the Docker, the application, or the daemon that is running the Dockers, is installed. So now I have prepared the Docker infrastructure, the containerization infrastructure that is required for me to run the Dockers. Now, there are two ways, or a couple of ways, but usually two ways when you are dealing with a single Docker infrastructure, a single Docker node. There are two ways that you can control those. The first way would be to go and run with the default command line tool. There is a command line tool called Docker that I'm going to show you. And this tool is intended to be a tool to connect to and to be able to do everything that the Docker is required you to. You can run them, you can push them, you can install them, you can upgrade them, you can see what images are there, and so on and so on. Now, the next thing that I need to explain before I even start this is something called the Docker lifecycle. And this is something that is pretty important, because what we are doing is we are creating Dockers, or we are creating different images, and once we have created this image, we can start it, then we can pause it, unpause it, stop it, and delete it. But the thing is that we need to make sure that we understand that we are basically doing two things. One is when we are creating the Docker itself, it is called image, because it contains nothing that can distinguish it between that image and another image with the same name. When we are running it, we are changing something inside it. Docker is intended to be stopped and deleted a lot. So usually when we are dealing with Dockers, we also need to deal with something called persistent memory or persistent storage. And this is exactly what I'm going to show you next. But the first thing that I want to do is I want to just check on my IP address. So I want to see what the IP address of this machine is. It is 1.189. And I'm going to quickly introduce another thing that I haven't yet used. And this is an application in Windows called MobiXterm. This is an application that is immensely useful when we are dealing with Linuxes, because it does two things. First, it enables you SSH connection to any Linux host. And the second, it enables you to run Xterm or X tunnels to connect to the remote X clients, meaning that you can run graphical applications on Linuxes that are remote inside your Windows browser. Right now, I don't care about those. I just care about the SSH. So what I'm going to do, I'm going to go to Quick Connect and just say, okay, I want to connect to my 1.189, if I'm correct. It's going to ask me which protocol do I want to use. You can see that a lot of protocols are here, including SSH, Telnet, remote desktop protocol, VNC, FTPS, FTP, serial, Windows Assistant for Linux, and so on and so on and so on. Now, I'll go with SSH, press OK, say demo. And the reason why I wanted to have this thing is it's much easier to read from the screen. I wanted the high resolution that it offers. Okay, now let's just quickly close this thing and let's see what we can do. Let's just press clear. And now let's say Docker to check if the thing actually works. Yes, it started. There shouldn't be anything running, so I'm going to go with Docker PS. And then it's going to tell me that I don't have the permissions, so I'm going to give myself permissions. So I'm going to switch to super user. Now Docker PS, nothing is running. Okay, how do I run Docker? I'm going to say that this is the easiest part. Let me run the Docker called Hello World. I'm going to go here to my Docker environment. And I'm going to go and find my Hello World Docker here. And there is a command line here that says how to actually install the Docker. Now, I can do it in two ways. I can use the Docker pull, or what I can use is just say Docker run Hello World. What's going to happen is that Docker is going to say, okay, I do not have the local image. I know that you're looking for Hello World latest. And since the Docker is going to by default go to the hub, the Docker hub, hub.docker.com, it's simply going to go there and say, okay, is there something called a Hello World? Since there is, it is going to try and pull it. So it's going to download the Docker itself, and then it's going to run it. Now, this is the newest version, so the latest version, and this is the tag that I was talking about. So it looked for the tag like latest, and then it started it. And what hello world does is it just display this text and then gives you some idea on how to run different Dockers. Now, if I say Docker PS once again, I'm going to see that my Docker is not running anymore. The reason is that you more or less can have two different separate applications or separate ideas of an application. One is that you have a Docker such as this one, where you download your Docker, you run it, it's a separate application and does something, then exits. So it's more or less like a regular application, like a snap, like a Flatpak. So an application contains everything that it needs in one place and then runs and quits. But this is not what Dockers are usually for. What usually you need and you want when you're running Dockers, you want to be able to run an application in order to have it running in its own environment, but run continuously. This depends on how your Docker was created. So, for example, I could run an Ubuntu Docker inside my Ubuntu. So I could create a Docker that is basically a copy of the operating system. And then I could go and just say this. So let's just quickly copy this and paste it. Now what I told it is, I told it to go to the internet, grab the latest version of the Ubuntu Docker, to run it, and then to connect to it. So -it means interactive. So what I'm doing is I'm now logged into the Docker inside my machine. So my Linux that is running the Docker service was named test Docker. Now you can see a different name here. It's called root something. And this is the machine that is basically running general Ubuntu. It is doing something, so I can have my own, I don't know, I'm going to go to home, see what users are there. Only user is Ubuntu. And this is a more or less just an empty virtual machine or empty Docker that contains the files needed to run the Ubuntu server. It is extremely small since everything that is needed for the Ubuntu to run is already included in Ubuntu itself. So what this Docker is basically doing is it just runs the application inside it, and it depends on everything else. So the kernel, the memory, and everything else, the kernel control of the memory on the Ubuntu that it is running on. Now this is all fine and simple, because if I go outside and then Docker PS, nothing is running. And this is basically it. If I do ps -a, it is just going to tell me that there are two images installed. Installed meaning that there are two images that we got from the internet. It says that the images were running. It says that the images were exited, so they finished running. And the last thing is they give us them names. Names are just generated so that you don't need to, since you can run multiple images based on the same Docker image, you need separate names. You don't want to need to remember the hashes, so it just gives them a name. For example, if I rerun hello world, and then if we say ps-a, it is going to create another Docker, and this is going to be from the image hello world, but it is going to be another container, and it is going to have a new name. This one is Dreamy Torvalds, for example. The reason why this exists is that because you can have multiple Dockers running from the same image. So you download the image, run the image, and then this image becomes a container or a Docker. And then when you are finished, your Docker remains on your disk as an image that has been run, so that you can actually do something about it. Now, this is all fine. It's easy to use the command line interface, and this command line interface is more or less pretty intuitive once you understand what you're dealing with. But it is much easier if you have something that gives you some sort of an interface. So let me change back to my Firefox and show you something that is much easier to use. Now, this is called Portainer. Portainer is both an open source and a commercial solution intended to be a management tool for Docker, which I said is a commercial name for the containers. A Podman, which is another name for containers usually under Red Hat. Then Kubernetes, which I'm not going to explain too much today. I'm going to be talking much more in the next episode about those. But the thing is that this is more or less a web interface into Dockers and into clusters of Dockers or clusters of nodes running Dockers. Now, what you want to do is you need to dig a little bit here, because you're not going to see that anything here is open source and free. What you want to do is you want to go to get started free, and then you want to see that there are different versions of nodes. You can get 3 nodes for free if you apply. You actually just need to sign up. Then you can create your own enterprise editions, and so on and so on. But if you go down and go here and install Portainer, you're going to see that actually you can choose between 2 editions, BE and CE. Community edition is designed for exactly what we are doing here, the home labs. So I'm going to go with install Portainer to CE now. The installation documentation is, I'm going to go with excellent, because it is going to guide you by the hand through everything that needs to be done. So it says, do I want to create a new Portainer, or do I want to create an environment to an existing installation? I'm going to set a new Portainer server, okay. Then it asks me, did I install Docker Swarm, Kubernetes, or Docker standalone? I have a standalone installation, so this is a single machine. Then, do I want to install on Linux, on Windows subsystem for Linux, Docker desktop, or in Windows? I'm going to go with Linux. And then it tells me that there are 2 things that need to be installed. Now, it says that I need the latest version Docker installed and working. This is what I did. I need to have sudo access to the machine. Yes. And then I need to be able to expose this port and use it on my network. This is specifically not directly needed, but if I don't, or if I'm unable to expose this port, I won't be able to contact the Portainer. So what's the point of installing it then? Now, then the next thing is that what you need to do is you need to use this command. I'm going to quickly explain why and what it does. When it comes to Dockers, and I'm now back to my SSH shell. When it comes to Dockers, just clear this thing. The Dockers themselves are intended to be basically throwaways. So the idea is that your application is running inside the Docker. You download the image, you run the application, it becomes in Docker. When it runs, it's fine. And then if you need to update it, you just throw away the Docker and just install the new version, just like you would with the regular application. The problem is the data separation between the host computer and the Docker that is running. Because I said that your Dockers are going to be completely separate from everything else on your host or on your Docker machine. This means, of course, that your application cannot write to disk of your local machine. And this means that you need to create some sort of persistency or a way that your data can be written to the disk, even though you are deleting the Dockers all the time. In order to do this, we are doing something called a volume, and this volume is basically a logical thing that contains the data. So if I tell it to create a Docker volume called Portainer data, it is just going to create something, and this something is going to be a directory that is going to contain data across the installations. So now, if I remove my Docker, this volume is going to still remain on the disk, and it is going to contain the data from the Docker. Now, the next thing that I need to do, I need to start and run my Portainer server container. This is simple. I just copy it and say, okay, go and paste it. I'm going to quickly go through the command line that I just copy pasted to try to explain what each part does. Now, what I'm doing is I'm telling my Docker to run. I want it to detach, so I want this thing to run in the background. I want this thing to map the local port 8000 to the Docker port 8000. I want to map the local port 9553 to the local port 9553 on the Docker. I want to name the Docker Portainer. I want it to be restarted always with the computer. I want to connect my local sockets from the Docker to the sockets on the Docker itself. I want to link my Portainer data volume to the directory /data inside my Docker. And then I want to actually do all of this with the image called Portainer /Portainer CE 2.21.5. Please note that this is not the latest image. This is the image that they want to do. So I'm just going to push enter here. It's going to pull. It is going to download the layers, and I'll go and talk about the layers next time in the next episode. But there go the layers. And now, once this thing is installed, and it should be installed, the only thing that is going to happen is that I'm going to get a long hash. This hash, if I ask it to do a PS, it is going to tell me that this hash, or this container ID, is from the image Portainer. It is running the Portainer. 20 seconds ago it was started. It has these ports mapped, and it is running as Portainer. So basically what this means is that something has been run. What is this thing? This thing is the Portainer itself, so the interface. Now I no longer need my SSH, because what I could do, I can just connect to the 9443 on this machine and check and see what I actually installed. Let me just check what my IP address is. 1.189. Let's go here. Let's go and say 168.1.189, and I said that I want my port to be 9443. Okay, it was requesting, it was expecting me to do the secure HTTPS, so it requires secure connection. Okay, I accept the risk. I'm going to create a password for this thing. I'm going to create it. And now I have my environment setup, but it is a little bit confusing because it throws me into the environment setup, although it already understands that there is a local environment, and this environment is called local, and this is what my local machine. So theoretically, I can connect to multiple hosts and have those hosts run different Dockers. Now I'm just going to connect. Now you can see on the left that this thing split. This is where I can choose my environment. This is my first environment I'm working with, and this is the administration for the entire stack or the entirety of the thing that we are going to experience today. Now, first for the logs, and I'm talking about the logs for the Portainer itself. You can see what happened when it happened, and so on and so on and so on. Nothing is here because this is a simple and the installation that I just installed. You can set up different environment things here. So you can say what is going to be the name of the Docker. You can manage the access to the Docker and so on and so on. What I'm mostly interested in right now is my actual environment, so the local environment, because this is where I'm running my Dockers. I can see that I have my 8 CPUs. These are the vCPUs that I used in the Proxmox. I have 16 gigs of RAM, and I have 0 stacks configured. I have 4 containers running, 1 volume, 3 images, and 3 networks. Let me go through what this means. First, I have the images. The images were the things that I downloaded from the internet. So the containers that were not run but first downloaded from the internet, the Hello World, the Ubuntu, and the Portainer. I use these two to show you something, so to just explain how the Docker works. And these are the images that are right now on the disk. What I can do is I can go and check where this came from. I can see what the path is. I can see what the layers are, so what the parts of the image, and I can delete this image from the disk. Now the images are fine. What you're going to do usually is you're going to completely ignore the images because you're going to be requesting those to be requesting them to be pulled from the registry, or you can theoretically push the registry, but this makes no sense in this particular case. I have no reason to push the image to the registry, and I have no permissions to do it. So I can just get the newest version from the registry. If I can press here, it is just going to say, okay, do you want to update? Yes, I have pulled the newest version of the image. This is basically the equivalent of updating. Now, the containers contain the things that I ran. So the Hello World was the container that I ran 2 times. Each time it ran, it created its own container. Make note that this thing now has exited. I can take a look at different versions of the container. It tells me, is it running or is it stopped? I can take a look at the logs. The logs should be simple. I can take a look at all the different configuration parts, including the connected networks or the networks that this Docker is connected to. Usually, Dockers are going to be either connected between themselves to a local network. This one is called Bridge by default, but you can create whatever networks you want. You can create them here. So Bridge, Host, and None. The second thing that you can do is you can have them connected directly via host to the local network. and you can disconnect them from the network if you don't need them on the network. Either way, you need to do it specifically for each Docker. So you can do it by the script, you can do it directly, but you need to create your configuration explicitly. There is no implicit configuration unless you're doing it in the default installation, the Portainer, as I'm doing it right now. Now, the last thing that is here is that I can also use the dashboard and the Portainer itself to create new containers and new Dockers. What I can do is, let's go and add the Docker. Let's say that I want to add Alpine. Alpine is another one, another Alpine test. Let's call it Alpine test, and let's say that it is Alpine. If I go to the Docker Hub, and if I search for the Alpine, you're going to see that this is something called minimal Docker image based on Alpine Linux with a complete package index with only 5 megabytes in size. So it's basically a Docker that is small and that can be used to create another Dockers. If you go back to my Portainer, sorry, here, if I say go to Docker.io and download Alpine, I can tell it to pull the image. I can then tell it to publish all exposed ports to random host ports, and I can tell it to deploy. What is going to happen in the background is that it is going to go and download the image, and you can see the Alpine test is running now. So what has happened is that this container has been downloaded and has been run. I can take a look at the logs. It says nothing is here. I can go back and I can see that it is stopped for a few seconds when it takes the code 0. The reason why it has stopped is because the Alpine itself is an empty container. It doesn't do anything. If I want to do something else, I either need to change the container itself, so I need to do something inside it, or I need to download a container that is able to do something useful. But more on that in the next episode, where I'm going to deal with stacks and try to explain how the networking between container parts work and what does it mean to actually create a Docker compose file instead of creating just a single Docker file. And also I'm going to be creating Docker files itself. So until then, I'm still Yasmin. This is still the IT show, or ThatITShow, and I hope that Vedran is going to join us next week with the great news. Thank you for being with me, and bye.